Welcome to Wineyard Technologies. The project discussed in this section is automatic temperature based light intensity control. So the main aim of this project is to design a prototype which is based on temperature. So according to the temperature, the intensity of this bulb varies. So let us examine this total project in a step-by-step procedure. So here we are using a microcontroller unit. This is a microcontroller unit, two transformers, one ADC unit and one temperature sensor, one regulated power supply. This is ULN driver and these are relay units. This is tagged resistor and this is the load, and at last this is the LCD. So here the temperature which has been sensed will be displayed on this LCD. So let's start from the power supply. So we are taking power supply 230 volts, that is step down by using this step down transformer to 18 volts AC, and by using bridge rectifier we are converting that AC to DC, and we have used one electrolytic capacitor to filter out AC ripples. As this microcontroller unit need 5 volts, for the purpose we are using a 5 volts voltage regulator 7805, and also we have placed one LED to indicate whether the power supply is on or off. And this is the microcontroller. The microcontroller which we are using is 8089S52. For this microcontroller it has 4 ports, port 0, port 1, port 2 and port 3. So for port 1, port 2 and port 3 it has internal pull-up resistors, whereas for port 0 it doesn't have any internal pull-up resistor. So for that purpose we have placed this external pull-up resistor of 9 pins which of the value 10 kilo ohms. And this is called reset switch. So the main purpose of using the reset switch is, if the program has been stuck in between and if we press the reset switch, the program will be started from the starting, and this is called crystal oscillator. So the main purpose of using the crystal oscillator is, as the microcontroller has inbuilt oscillator but it doesn't have any specific speed, so to provide that speed we are using crystal oscillator, and its frequency is level 0.0592 megahertz. This is about microcontroller unit, and this is LCD, liquid crystal display. So the main purpose of using LCD is it will display the temperature. So it is having 8 data pins, 3 control pins and 1 variable resistor to change the contrast or else the brightness of this LCD. And this is ADC unit, analog to digital converter, and this is the temperature sensor, which are a 3-pin temperature sensor. One input, second one ground, and third one is output. And this is preset. The main purpose of using this preset is we can change the sensitivity of this temperature sensor. So the temperature which has been sensed is given to this ADC unit. This ADC unit will be converting that analog values to the digital values, and that is given through these wires to port 3. And according to that values, the microcontroller will be giving the same data to this port 1, and that is connected to LCD, and that is going to display on that. And for controlling purpose, here we have used a ULN driver. Actually, to drive these relays a high current is required, so but the microcontroller output current is 1 milliamp. That 1 milliamp current is not sufficient for the relay to turn on. So this is ULN driver. The main purpose of using this ULN driver is to turn on the relays. So this ULN driver acts as current amplifier. So here we are using 4 set of relays to show the intensity of the light. If the first relay is on, the intensity is less. If the second relay is on, the intensity is still more. Third one still more, and fourth one is very high. So the output for this ULN driver will be given to the relay units. These are the 4 wires which are given to the relay units. and the input to this ULN driver is given from port 0, and the output of this relay units is given to tagged resistor. This is the tagged resistor. The main purpose of using the tagged resistor is it varies the brightness of this load. This is the load which we have connected. So now let us see the working. So initially the temperature is, you can see here, 17 degrees. So now I am with this lighter, now I am switching, now I am increasing the intensity. So you can observe here. So the intensity is more, so the LED is on. That means the load is on. So now as this temperature sensor will be in decreasing mode, here you can see the temperature is 66 and slowly it is decreasing, 59, 56. So now when the temperature is 40, the relay, third relay is on. That means the intensity of the LED of this load has been decreased, and again it is decreasing, and at last it will be coming to the first relay. You can observe the temperature here, 33. So at 33 the first relay is on, at 40 the second relay, at 50 the third relay, and at last at 60 the fourth relay. Now this will be off when the temperature reaches 15 degrees. Now again I am showing the output here. So you can see the temperature is 52 and the third relay is on. So like this we can show the output. So the main advantage of using this project is, according to the temperature we can change the speed of the fan also by using the same project, and also we can change the intensity of the bulb. Thank you.